What is going on, everybody? Welcome back to the channel. Looks like I need to adjust my levels just a little bit. We are back in the office this week for our podcast. Today we are going to talk about yesterday's video. The reason we're going to talk about yesterday's video is because we want to... That video had the response and the result that I thought it was going to get, and that is that people are constantly arguing these myths, and I think what happens is further questions come up, and so let's kind of have a clarification thing. There are 5 kind of areas in that video yesterday. We're going to dive into them. If you have questions about the nerdiest of minutia of guitar stuff, now is the time to ask them. You can put it in the chat over there. You can use a super chat if you like, and we will do that. We will help you out with that. Do me a favor, go to DylanTalksTone.com and check out our pickups. That's what we do. We are currently, see all those wires sticking out right there? I made a ton of Telecaster pickups this morning. We are not only trying to keep up with everything, but we're also going to go do the Amigo Guitar Show in Nashville next month. So if you want to meet us there, that's cool. Also, go to Dylan Talks Tone and enter your guitar in the weekly and then monthly Rig of the Week contest. And we're going to give away some Lizard Spit stuff that has been sponsored by Lizard Spit this month. So we appreciate Chris for sending us that stuff. So let's talk about this a little bit. The idea behind our conversation today is I don't really want to argue with anyone. There's nothing to argue. Science is science, okay? But I think as we analyze what we talked about yesterday, I think a lot of folks have misunderstandings about terminology, and sometimes that's what sends us down the wrong road. Now, we don't want to get all into semantics for the sake of arguing, because there's people that do that, and we're going to talk about that, and that's freaking annoying. You need to stop. However, having an understanding, a general understanding of what's going on will help you when you're troubleshooting. If you ask the wrong questions, you'll get the wrong answers. If you have a problem with your guitar, if you're trying to fix something on your guitar, and you ask the wrong questions because you're using the wrong terminology. If you text me on the chat on the website to ask a pickup question and you use the wrong words, then I have to spend a bunch of time trying to figure out what does this person really mean and really try to help you. It happened last week, and somebody actually ordered the wrong pickup because I could not figure out exactly what they wanted. That doesn't happen to me very often, but it does every once in a while. So we're swapping some things around. We're getting them sorted out, but that's what can happen. So we want to make sure that even though all of the science is correct, and all of the science is correct in everything we said yesterday in that video, because of language and things and terms, then myths can grow out of those things. Misunderstandings can be had. People can sort of be half right and half wrong. And so then what happens is those things get perpetuated into myths. And this is a funny one to me, the kind of person who gets in the comments and says, well, as a naval electronics guy for 40 years, as a guitar tech for 40 years, as a luthier so the only thing that age does, there's a fair possibility that age, all it does is it replicates a mistake for longer. Okay, so if I'm doing something right and you're doing something wrong, and you're older than me, you've just been doing things wrong longer than I've been doing it right. That's all that means. So we just need to make sure that we get everything sorted out. We want to understand where this stuff comes from. Now, at the end of all of that, if you don't believe me, or you think I'm wrong, or you want to continue to do things the way you want to do them, that is absolutely your right to do. That's absolutely your right to do, and we're totally cool with that. And sorry, the 3D printer is stopping something. I think it's done. So one of the things we're going to talk about right now, let's jump into this, is ground loops. So immediately yesterday, people jumped in the comments and they said, well, I've seen a video. One of the main things that came up in the comment section yesterday was, I said, You can't have a ground loop in a guitar, which is correct because the ground only the guitar is only one node of a bigger system. Therefore, you cannot have a loop within the ground loop within that node. Okay, that's science. Okay, and if you want to go dive deeper into that, you can watch that video from yesterday, and it'll run into that. What we want to get to though is a bunch of people in the comments said, well, there's that thing on Lindy Fraylin's website, and so what you're telling me is Lindy Fraylin is wrong, blah, blah, blah. No, he's talking about something different. He's talking about something different. So what he's talking about is if you take a wire and you put it around in a circle, you can create a single turn coil that can attract noise. So that is not a ground loop, okay? That is not a ground loop. A ground loop has to have, and this is the other thing we're going to get into here in a minute, a fair amount of current and then a current differential to cause a ground loop. A guitar is not a power distribution system, okay? It's an electric motor. And so it's an inductor. That's basically all it is. And so just because we have a circle of wire doesn't mean that we have a ground loop. And actually, just because we have a circle of wire does not mean that we have a single turn coil. In most guitars, it does not matter how you ground your guitar, you will never have a single turn coil. The one exception to this could be, but usually is not. If you take a piece of wire and go all the way around all 4 pots in a Les Paul, you can create a loop of wire that could be, in a certain circumstance, which isn't usually in a guitar, a single turn coil. That could happen. How do you mitigate that? You just don't connect one of the ends. You just make it to where it goes around in a circle and then to your ground, but it doesn't go all the way around. That's all you do. So that's not a ground loop. That is a single turn coil. There's a difference. And the way it introduces noise into the guitar is also different. And the probability of a single turn coil in a guitar producing noise in that guitar has to have a bunch of other conditions present outside of the guitar when we start talking about EMI and RF, stuff like that. So I understand where the misunderstanding comes from, but this is worth diving into a little bit. So if you have 4 pots in your guitar and you have these components around in a circle, just don't connect them. You can ground them all like this, from this one to this one to this one to this one. Just don't go back to this one, right? Have your output jack come off of here, and there doesn't have to be then there's no single turn coil. There's very few instruments where this can be a problem. As we discussed yesterday, a ground loop takes a differential in current, which we're going to get into in a minute because that's another thing that people had a big issue with. One of the other things that people will talk about is, well, what if I touch my strings and the noise goes away and I let go of them, then there must be a problem, right? No, that's how a guitar works. You are part of the ground when you touch the strings. Therefore, the noise goes away. If you let go and there's more noise, the guitar is acting perfectly. That's how it is supposed to work. So that is a really, really important, these are really, really important things to think about. I've got notes here because I don't want to forget any of these little details. So there still is no ground loop. There still is no ground loop. What you're doing is you're creating, you know how we talk about a guitar pickup is a coil, obviously, and so it acts as an antenna which attracts electromagnetic interference or radio frequency interference. That is what we're talking about. When you create a single turn coil, it could happen, but the circumstances have to be very, very specific. And a single turn coil also, the effective field around that is way, 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 way smaller than a regular guitar pickup. So usually usually if that were to happen, the noise that would be created by that would be masked by other things in your noise floor, and you probably wouldn't even notice it. If you want to be super, super precise about it, and you want to make sure that you're completely eliminating all types of noise, you could make sure that that doesn't occur. But for most people, in most situations, in most guitar playing environments, they're not even going to hear the difference. Now, you could put it on an oscilloscope and you could see it. You could watch the little thing go like this. But that doesn't mean you're going to hear it. Just because you can see it on an oscilloscope doesn't mean you can hear it. Also, when it is within other noise, it can disappear within other noise. If it is additive, that's different, but the pickups are typically going to be more than that. Okay? So these are just some things to think about. So yes, it can matter. So people were not wrong in bringing up the concern. However, it is still not a ground loop. It's not a ground loop. Get that out of your head. And it's very, very, very important to know the difference, because when you're troubleshooting your guitar, when you say, I have a ground loop in my guitar and I'm trying to help you fix it, you don't have a ground loop in your guitar, and we're chasing a problem that doesn't exist. If you say, I'm having noise in my guitar, what can I do to eliminate said noise? Well, let's look at shielding. Let's look at how noisy your pickups are. And let's see if you have a single turn coil inadvertently somewhere in your guitar with the way you've got it set up. And we could eliminate all those things, and the guitar will probably be quieter. Does that mean that the single turn coil is a big part of that puzzle? No, it's a very, 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 very small part. But if you want to be thorough and a completionist, then I respect that and I would help you do that. So this is really important to understand. We want to be real precise about these terms because of our troubleshooting. All right, let's go through this really quick. And we should say that most of the people that brought this up are turds. They're not even bringing it up in my favorites are tremolo bridge and input jack. I always say output jack, but yeah. The other thing we should talk about too is somebody brought up some stupid thing about not calling it ground. Look, like tremolo, there are certain terms in the industry that people understand. And I'm not going to stop saying ground. Ground comes actually from radio transmitter stuff. And your house is grounded, and therefore it physically is grounded. There's like a pole that goes in the ground with a wire on it. And that works back to and affects your guitar, like through everything, and comes back to your guitar. So you are grounding a guitar. Whether you like that being called that or not, you can get over yourself or get some therapy or whatever. But that right there, the return path or whatever they want to call it, screw that. Now, I will say one thing is important about return path is that remember that signal travels from negative to positive and not the other way around. So when you're hooking stuff up, like a coil split, for example, what the negative to ground, or whatever one goes to ground, is important, because the first one that goes to ground is going to be the one that cuts off. So understanding return path is important in a couple of places, like a coil split, for example. And we could go down that road in a different video, but that's an example of where understanding that it's a return path is important. Avoid unnecessary circular connections. The whole star grounding thing is dumb because it doesn't fix that, actually. It doesn't fix the problem, really. What it does is it keeps things less confusing, but guitars aren't confusing anyway. There's only like 4 things hooked up in a guitar, so you don't really need to worry about that. Let's see. Blah, 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 blah. Just making sure that I got all this stuff. Okay. So thank you to the folks that brought this up, though, because it's important to understand these concepts. And of course, I didn't have time to talk about them in the video yesterday. And actually, thanks for bringing up the Lindy Fralin thing, because that whole thing is an interesting. It's an interesting thing. Okay, the other thing we want to discuss here that a lot of folks wanted to talk about is the current situation. That current, I said that current doesn't exist in a guitar, which isn't entirely true. So let's dive into that a little bit. We're talking like microamps, milliamps of current. And when we're talking about a ground loop, or we are talking about, for the purposes of this conversation, they can be measurable with a meter, but they are not measurable in the sense, because a guitar is not, it passes signal. It does not generate current, okay? And so typically in a situation like this, current rises because of load. So in an amp, it's because of the speaker and the transformer and everything that's going on there. In the power supply side of the amp, it's creating the voltages to move the amplifier, right? And so we have load. We have load there that is raising current, right? It draws and it raises current. When you have two different current draws there's a differential between those current draws, therefore you have a possibility for differing ground potential causing these issues. But now in a guitar itself, there is not enough current there to have this whole draw situation. There's no actually, to be honest with you, in the strictest sense of the word, there is, I guess, with a capacitor and a resistor, we could say that we're creating a load, because as we turn the volume down, for example, we're loading the pickup. But this is not creating a current differential between a bunch of components to cause noise. Okay? It's just not. There's just not enough there. And so, yes, it exists. And yes, the numbers, you could probably show it if you, somebody brought up a formula and said, well, if you've got 500 millivolts and you've got this many, kilo ohms in the pot, then it's such and such and such milliamps. Okay, correct. You're right. And I'm wrong. So you're right. However, the practical application of that still does not put us in any sort of current draw situation where we have a ground loop in a guitar. It just doesn't. It just doesn't exist. It cannot. Okay? Still, it cannot. So thank you for the clarification and bringing that up, because it is important. You want to understand that mathematically it exists, but not enough. Not enough. Let's see. I'm going to go back in the comments here and we'll keep going. This is great. I love these conversations. I'm confused about the difference in hum from touching my strings versus touching the outside of my instrument's cable plug. So that depends on how your guitar is grounded, to be honest with you. Yeah, and here we got people want to make a big deal about ground. Whatever, dude. So when you touch the strings and the noise goes away with humbuckers, that's normal? Yes. Yep. Because even with a humbucker, you're still going to have the antenna base, the antenna base of the coil doing what it does. It's just canceling out most of it. But a humbucker is like stainless steel. It's stainless, not stain proof. It humbucks, but it doesn't hum proof. We still have hum, right? So there is that. Earth and or common may be better choices, but it's not, because common, for example, is an AC term, and we don't use that the same way in a guitar. We could, I suppose, but that would be even more confusing. The problem is that when you're trying to learn this stuff and you're trying to troubleshoot stuff, you do have to stay kind of with industry standard terms. Otherwise, people are completely confused by what you're talking about. It's like talking about you may live on the other side of the pond from me, and you may talk about walking on the pavement, and I think that's the street, and you're talking about the sidewalk, right? Two completely different things, and over here, that's the difference between you getting hit by a car or not. So the same thing with this stuff. We sort of have to understand the terms in order to be able to, in order to be able to understand this stuff. I love the conversation though, because it really does. It's important to have them, right? It's important to have them. Okay, let's talk about the other thing that came up yesterday that everybody wants to talk about because I don't understand why this is so important to everyone. But this whole thing about orange drops being flipped, okay? They do not have polarity. Again, this is another thing where we need to understand terms. There is no polarity in an orange drop cap. There is not, okay? What there is a foil end, okay? Well, there used to be. There used to be a foil end. The way they used to make caps, and you can look this up. I can't remember what the term is called. It's how they radially wrap them, but basically, and how they hook the electrode, the wires onto the ends. But basically, if you look up the maker of orange drops, you can go read all of their technical. I spent hours doing this last night because I know I'm right about this, and people want to argue with me about it. And here's the problem. Time. It used to be that when you rolled up a foil cap, you roll it up like this, and it would make sense. If you, think about it, when you're at McDonald's and you roll up a straw with your finger, you roll up a straw paper with your fingers, right? There's one finger that has the wrap around the outside, and then the other finger is on the inside, and right? That's exactly the same way a cap used to be made. They would roll them up like that, and one end would be on the inside and one end would be on the outside. So if you take the one on the inside and put it towards ground, then that would make it quieter, because as the signal comes out, then it's shielded from itself. The problem with that is, and so then you would say, okay, well, if I flip it over, then theoretically it would be noisier. And there are people who have done these experiments, and they have hooked it up to an oscilloscope, and they have, for example, said all this stuff, and this is how it works, and this is what we're going to do. Apparently my hard drive is trying to be full on me right as we are discussing things. So let me delete some stuff so we don't crash. Okay, so that used to be a possibility. The problem is that the way they make caps now is different. They extend the foil beyond the wrap, basically. And you can read about this. You can go read all their technical documentation. There is PDFs and PDFs and PDFs. I don't know why. It's literally telling me disk space is getting low. There are PDFs and PDFs, and you can go read all of it. And the other thing about this is that the construction is different from the 100 to 400 volt orange drops, and then it's different from 600 and up. And you don't use those in your guitar. Those are for amplifiers and stuff. It used to be a problem, so they would put a mark on the pickup, are on the capacitor, and then you could flip it around. There would actually be like a line on one end of an orange drop. But they stopped doing that about 10 years ago, 15 years ago. And now the company that owns Orange Drop and Vichy Sprague doesn't do it anymore because it is a non-thing. It just isn't a problem like it used to be because they changed the construction. And you can read about all of that. It's like super easy, not super easy. It's sort of a lot of Googling to find. But there's a bunch of PDFs that show all their data sheets. And it actually says, I should have screenshotted it so I could read it to you. But basically, there's a term for how it's wrapped up. There is a term for how long the foil is out the ends to where the leads are hooked up. And then there is a term for how the whole thing is covered up with polypropylene. And so it basically is not done the same way anymore. They do it different. So what I would tell you is, if you're one of those dorks that has to make a big deal out of this, continue being one of those dorks. Just don't do it in my inbox. Because you will be fine. For the rest of us who actually like stuff and smile sometimes and, play with our puppies and have lives and people that like us and stuff like that, then we will be totally fine no matter which way our orange drops are in our guitars. If you are in, a completely ridiculous to get along with person and you need to make sure that you hook up every orange drop to an oscilloscope, you are free to do it. But we're not going to be very good friends. We're just not. Let's see. Let me go through some of these. If these capacitors had polarity, there are millions of defective guitars out there. Yeah, see, and that's the thing. In a guitar, I always say this again and again. If this is a smartphone, then a guitar circuit is the dumbest circuit ever, okay? So there would be people, and I know right now, if I call up Brian Wampler or if I call up, Bob Keeley, or if I call up anybody, any of my friends who make stuff, I could call up Andy Fuchs, and he would tell me that he does not sit around. I know they do not sit around with an oscilloscope when they make pedals, for example, which are far more susceptible to all this stuff than a guitar, because there are differing voltages, there are differing current loads, there are all kinds of, and much, the voltages in pedals, it has to be controlled, between this voltage and this voltage, and the capacitor has to store for a particular amount of time, and there's all kinds of things, right? The decay of the capacitor and all that. There's all kinds of other numbers that smarter circuits than guitars, because guitars are the dumbest circuits on the planet. So they need to worry about that stuff a lot more. And I can guarantee you that if I call up Bob Keeley right now and say, yo, do you take all of the orange drop caps that you use and hook them up to a scope and decide which way you're going to put them, and then lay them all out on the table to make sure they don't accidentally get flipped over before you put them in the pedal? He's going to be like, that's a bunch of crap. No, we do not do that. I know he's going to tell me that. And if he's watching this for some reason, then maybe he could call me and tell me different. But I'm gonna live and die by that. I'm gonna live and die by that. That's gonna be a thing. Man, I hope we don't have problems with saving our podcast here. Anyway, wrong. The dumbest circuit is inside of some poor guy's forehead. Yeah, I mean, all foil wound capacitors will have inductance, but not much. Yeah, they will. But the thing is you got to think about what sort of percentage we're talking about here, because we're not talking about a large percentage of anything. That's the thing. These are very, they're just non-issues. They're just non-issues. And if people want to continue to bring them up and make big deals out of them, like I said, you are welcome to do so. I am totally fine with that. Hang on. I really need to do this. I don't know why, but this is like, I edit so much video that apparently a terabyte is not enough anymore. Yeah, this is an interesting conversation, right? I love having it because it just really exposes, this is an interesting thing too. It really exposes the people who want to play guitar and the people who want to argue about guitar. Which I don't understand those people. Okay, there we go. We just deleted like 400 gigs of stuff. So let me ask you, are you a guitar enthusiast or are you a guitar arguing enthusiast? What are you, right? And I'll guarantee you right now that all the music that you have on your old-fashioned iPod, like all your mullet rock, all of that stuff, nobody cared which way the capacitor was turned. And nobody cares about any of it. No guitar builder right now who's making more money than the person who's arguing about it, building guitars, and having fun building guitars for a living, is, while you're selling insurance on a Tuesday, arguing about this, that dude's not thinking about which way the capacitor's going, and he's selling bunches of them, and he's having a great life. So it's just a super annoying thing. I don't understand why people do it. Let's see. The RF argument, so we talked about that. Polyfoil is not polarized. If you want, and you know which way the foil goes, put it towards the ground. Or the return path, if you want. That's what I would say. But don't be stressed about it. Don't be stressed about it. Okay, the other thing we want to talk about, there's a couple of things we want to talk about here, one is the solder argument, and not how you say it. I respect anybody who wants to say it differently than me because we all live in different places. Not in a yellow submarine. Okay, so the whole SN60 versus SN63 thing, the 40, 60-40, 63-37, there are a bunch of people, not a bunch, but a few people who wrote, I didn't even read it, it was like TLDR stuff, like way long comments about how it degrades signal, blah, 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 blah. Well, let me tell you, 6337 is often used in wave soldering for circuit boards, okay? It's a different process. So through-hole soldering like you do on a guitar is different than wave soldering for a circuit board. And what that means is what they do is they put all these, and also micro soldering, when they put all of these circuit board pieces in a circuit board, right? They actually, I don't want to say submerge it, but for a moment, hot solder comes in contact with the board and immediately sticks and solidifies. It's called wave soldering. And for lack of a better word, if you push water and you create a wave and it gets higher in this spot and it comes up and touches the circuit board, a wave of solder just comes up and touches the circuit board like that, it has to do it in an instant. Otherwise, you don't have a good solder. And that's a very poor way of explaining how they do everything that's sitting in front of me and in front of you. So your phone, your iPad, your TV that you're watching this on, your whatever, every little circuit board, anything, right? This keyboard, like any circuit board, anything is done like that. It's probably using 6337. So it has to be done in an instant. It's not again, it doesn't have anything to do with the eutectic nature of the blah blah blah. It's literally a function of the process, how the process is applied. Through hole soldering, like what we do for making guitar parts, that's not necessary, because we have more time. So we don't have an instant. We have however long we want to take. And so, it's just not that big a deal. And so when you solder that way, or when you use that solder, if you don't do it right, you can have cold solders too, because they've got to be done right. I don't like using 6337. I don't at all. I'm still trying to understand what this man is talking about. I'm just here. I'm glad you don't know what I'm talking about. We're going to get to that in a minute. So you stick around for a second, and your comment is going to become very important in just a second. It's really a reliability thing. It's a mechanical thing. And also, a lot of the numbers and a lot of the tolerances for that stuff was all military spec stuff. And as we all know, mil spec stuff is usually crap because it's the cheapest, or it's the fastest, or it's the, whatever. So don't stress about it. 4060 Kester is amazing. It works awesome. Everybody every guitar that you play is probably done with a 6440 Kester or something close to that, or some sort of lead-free thing, which is worse. Lead-free sucks. But to be ROHS compliant in certain countries, and in Asia and a couple of places where they make stuff, a lot of that ROHS compliant stuff is lead-free, which is even worse. It's even slower. So if anybody says that I'm using 6337 so my signal is better, but they play a PRS SE or a Squire or anything, really, it's probably done with lead-free solder anyway, which is worse. So there you go. It's just a non-argument for any of that stuff. What it really comes down to is failure rate under mass assembly. So if you're assembling, like I said, computers, phones, anything, circuit boards in a home receiver, any of that kind of stuff, you're really worried about the reliability of the process over a period of time, and that is a mechanical thing, not an electronic thing as it relates to how conductive the solder is. And again, this would be another thing where if we cared about this, we would not be having this conversation, because lead-free is worse when it comes to this, and people still want to argue about it. 6040 at 700 is all I know. Yeah, that's Fahrenheit. That's about what I do. Well, I solder at 800 because I'm a freak. Brianna solders at 700, and you look at our solder joints and they look the same. It's just a matter of time. Sometimes what you do on it's the speed and probably some of the materials. I wouldn't solder at 800 if you're doing a lot of humbucker wire, because that's a thing. Ground loops are real, especially if you play with 2 active amps and stereo pedals. Yes. Yeah. Totally different situation. Not the guitar. But yes, exactly. All right. Let's see. There are specific US, EU, and other countries' laws on how to wire IEC mains and fuses. Yes, exactly. Yeah, don't get your guitar pick backwards. You do know that, right? That when you have a guitar pick, the name on the guitar pick is supposed to go towards your thumb. If you don't do that, it won't sound right. The name is supposed to go towards your thumb. Just making sure. let me just make sure we're going through here and making sure everything is cool. Making sure we're keeping up on all this stuff. Okay. Stop saying grounded. Oh, good grief. Get a life. Okay. Okay. So let's go back to, real quick, and this is what we're really all coming down to. Tone-sensitive picks should not be used. I agree, and also sensitive people should not play guitar either. They should play like ukuleles, more coffee shop, more acoustic, you know. That's where I would go. Man bun kind of deal. Go lean that way. If you're going to be super sensitive about grounding or solder versus solder or anything like that, and it's going to bother you that much, I would lean more acoustic, lean more coffee shop. Put more, drink less black coffee and more macchiato. Like, lean more macchiato. You'd probably be better off. Dye your hair green. I don't know. Okay, so I want to go back to. I'm sitting here with somebody. This dude was sitting here and he's like, I don't know what's going on. All I know is I'm here. Okay, this is why these conversations are important, but also not. We don't need to worry about this stuff. The video that we made yesterday, the point of it was to show, and I think it did a good job of it, and the follow-up comments and this conversation today did an excellent job to show how absurd all this stuff is. Somebody said to me yesterday in a comment, they said, last week, I'm glad that you're back to the myth-busting thing, because last week when you made that video about how we need the myths, I hated that. The point is this. That video yesterday was to show how absurd this stuff was. It really is. It's super dumb, man. Like, there's, okay. If we think about, if you're gonna order a set of pickups right now, let's say you're working on a project and you're like, okay, I want to order a set of pickups. Do you need to ask all those questions? When you build my Telecaster control plate at DylanTalksTone, which way is the orange drop capacitor going to be facing? No, you don't need it. You don't need it. You don't need it. What pots should I get because I'm getting a humbucker? That's a valid question, right? That takes a pretty big swing at stuff. What solder are you going to use? Well, sometimes depending on where you live, it can kind of matter. But most of the time it doesn't. So, what solder are you going to use? Are you using 6337 on my not backwards capacitor because I need, like the most amount of mojo in the backwards forwardsness of everything, right? Like, it just, you understand, I'm sounding ridiculous intentionally, but literally that's how ridiculous it is. So, the guy who messages me yesterday and says, look, man, I got a dog ear P90 and it sounds okay, but I'd like more clarity. What can I do? Well, what pots do you have in it? I got 500s in it. Okay, what pickup is it? It's such and such, this brand, whatever. I'm like, well, you could either do this, or this, and very basic stuff. Maybe go to a 22 cap, maybe from a 33. Make sure you have 500K pots, and if you still don't like it, then replace the pickup. Easy, right? There is no, but what does the oscilloscope say, right? There is no ridiculous's. It gets so ridiculous. And what happens is, and this is an interesting thing too, culture-wise, if I were to challenge somebody to say, and I have done this, call me right now. we'll record it on video and we'll put it on the internet, and I want you to have a conversation with me about why this is important to you. Nobody does it. Because A, they're either trolling, or B, they know it's ridiculous. It is ridiculous. Don't be that guy. Don't be like, what you're doing is you're sucking the fun out of the room, right? If the question is, hey, I have a muddy pickup. Bro, this dude wants to rock. Okay, how do we help him rock? If the question is 6337 or 6040, and then you argue with me about it over, like the high fidelity nature of whatever, those are two completely different conversations. And while we're over here talking about how to make this dude rock, you can be over there in the corner, doing something else. Like, I don't know. It's just a weird one. So thank you for saying, I don't know what I'm talking about. I'm just here listening. I don't want anybody to feel the need to have to get this nerdy about how a guitar works. I hate that for people. I really, really don't like it. I really would rather people be like, yo, this is what I want, man. I want to sound like, if you think about it, and we go back to that myth video from last week, you kind of want, hey, man, I want to sound like Slash. Okay, well, what does Slash sound like? Pretty traditional. Pretty traditional sound. A little hotter than normal. A2 magnets. Yeah. Try our Thruxton humbucker. That'll get you close. You're not going to sound exactly like him because you're not Slash. He plays a Gibson, so his pots are on a plate. But does that mean that I need to worry about whether I have a ground loop in my Les Paul or not? You know what I mean? Like, you could just take it too far. You could be that guy who just like takes the joke too far. And that's what happens. So thanks everybody for contributing to this conversation in a way that, like, you want to know the answer, you want to understand, you want to get better at this stuff, and you want to but you want to enjoy the hobby. It's called playing guitar. We're having fun. We're rocking out. We're making music. That's what we're doing. If you want to argue about stuff, go to Reddit. This ain't Reddit. You know what I mean? You guys, this is awesome. This has been super fun. Thanks for hanging out. I hope you all have a good day. And I have a really interesting video for tomorrow.